Hey class, this video is going to be on the review for the final. What I'm going to do is I'm going to go over the packet, the review packet that you guys have gotten leading up to the final. I'm going to go over the later problems, which are from numbers 19 and after. Okay, so I'm just going to get started. So for number 19, it says which equation best represents or best describes fits the data from this scatter plot. Okay, the answer for this is A. Alright, I'm looking for which equation best fits this line. I'm just going to draw a line that I think best fits it. Okay, so this line goes through all the points, and yeah, so this best fits it. What I'm going to do is I'm going to look at number or letter A. Okay, this equation is in slope-intercept form. We have y equal to negative 5 or 3/5 x plus 7. Okay, when this is in slope-intercept form, the b term, the number that's by itself, that tells me where I begin. Okay, that tells me where it crosses the y-axis. And our m is the slope that tells us where we're going to move, where we're going to more specifically rise and run. Okay, so if I look over here, I'm going to begin with 7. So 7 on my y-axis. It's actually right on this line that I just drew. And how much I'm going to move, my rise or run, it's negative 3/5. That means I'm going to rise negative 3, meaning I'm actually going down. So from this point, I'm going to go down 3. 1, 2, 3. And my run is 5, so I'm going to go 5 to the right. So 1, 2, 3, 4, 5. Okay, so right over here. And if I were to draw this, connect these 2 points, draw that line, I get a line that best fits the data. It goes through all these points. It looks like it describes it very well. So that's why it is A. A is our answer for this one. Okay. Number 20. Use a diagram of the figure below. Now we have a triangle here, and it's asking us which expression represents the perimeter of the figure. So this lines into, yeah, we have to know about what does perimeter mean. Perimeter just means it's the distance around an object. Okay. So instead of me adding those distances, we have expressions. We have 4x squared minus 9, 2x, 3x squared minus 6x plus 12, and all I'm going to do is add them. Now, when you add them, you need to make sure that you are combining like terms, so I'm just going to write this right over here. So I'm going to just write all 3 expressions. So the first one, okay, the second one, and the last one. And combining or adding like terms is incredibly important here, in the sense that I need to make sure that if I don't do this, then I could potentially make a mistake. Now, of these terms, let's identify what's a like term with 4x squared, 3x squared. When I combine these, it gives me 7x squared. Right? Let's do this 2x. Like term with that is negative 6x. When I combine those, it's a negative 4x. And the last one, we have our constants, our integers, which are a negative 9 and positive 12. When I combine these, it is a positive 3. So looking over here at my answer choices, I'm looking for 7x squared minus 4x plus 3, and it is B. B is our answer for number 20. Alright, number 21. 21 says in the equation, we have square root of n equal to 3 radical 4. Okay, what is the value of n? There's a whole bunch of different ways that you could go about solving this or simplifying it. Let me just write it over here then. Okay, so we're going to have square root of n equal to 3 radical 4. And it's telling me what is n. It's telling me, you know what do I put into here to make sure that it's equal to this? I don't have n by itself. A way that I can isolate n is by getting rid of this square root. Okay, so I want to find the inverse of that. The inverse of that is squaring. So I'm going to square the left side. And since this is an equation, we want to keep this balanced, we're going to square the right side. Okay. Well, squares and do square roots, they get rid of each other. We have n equal to. And for here, when I square this expression or this term, I want to square both of these kind of separately, right? So 3 squared is 9. And I'm just going to cover all this stuff up. When I take the square root of 4 squared, keeping in mind that squares undo square roots, so squares undo square roots, what does this simplify to? It's just 4. So I'm actually going to multiply 4. Okay. Oh, some simplification is required here, and what we're going to do is just multiply 9 and 4, which equals 36. So n is equal to 36. Okay, so for our answer for here, would actually be on the back side, it is letter B. Okay. Alright, moving on to number 22. 22 through 23, I believe is all true and false. For 22, it says the expression, and we have a coordinate here, it says negative b over 2, comma, f of negative b over 2. And we're saying, you know what, is that called the vertex? Okay, this is true. All right. When we have an equations in standard form, ax squared plus bx plus c, we've done this in order to find our x term, we set it equal to negative b over 2. And by finding your a and b, we plug that into here, and that is what gives us our x coordinate, our x coordinate of a vertex, always x comma y. Okay, and once I find that x, what we do is we put it back into the function. I put it back into the equation, and that's what this part, this y part, or function, is getting at. Okay, so this is true. All right, this is how you find the vertex, given that we have an equation in standard form. If I were to have an equation in vertex form, which is super easy to do, or super easy to find the vertex, so we have f of x equal to a x minus h squared plus k. This is in vertex form, where my vertex for this would be h comma k. Remember, it's always the opposite of the inside of the parentheses, and then our constant, which is our y coordinate, where we're going up and down. All right, for number 23. Number 23, it says when b squared minus 4ac is equal to 0, the equation has one solution. Okay. Now, this part here, b squared minus 4ac, it may look familiar, and the reason I say that it may look familiar is that it's in the quadratic formula. Okay, x equal to negative b plus or minus, inside the square root we have b squared minus 4ac, that looks familiar. So this part is actually right inside the square root. Okay, and we did talk about this. There are three cases where inside the square root is positive, 0, or negative. Okay, if this number happened to be positive, so if it's greater than 0, how many solutions does it have? It has two solutions. Okay, when inside the square root it happens to be 0, it has one solution. And when it is a negative number, well, if you have a negative number inside a square root, that can't happen. So it actually turns out to have no solutions. Or sometimes we call it imaginary solutions. So we've actually already answered our statement here. 0, when b squared minus 4ac is 0, we have one solution. So this statement is a true statement. Okay, but I would like for you guys to make sure that you guys are understanding this. That if I were to give this to you on the final, you would understand, yep, positive solution, or positive inside the square root, it has two solutions. Okay. Number 24. 24, so I'm just going to read it. It says, let x squared minus y squared equal 8, and x minus y equals 2. What is the value of x plus y? Now, a bunch of different routes to try to arrive at the answer. You could try to plug in stuff into here, but this part right here, this x squared minus y squared. If you look at your notes, when we talked about multiplying polynomials, we ended up talking about special products. And this y, or x squared minus y squared, is a special product. We call this a difference of squares. Okay. The difference of squares, so I'm going to give you what the equation is that if I multiply x minus y, that binomial, times x plus y, it's equal to x squared minus y squared. Okay, and it's true that if I were to multiply it out or distribute, we would get x squared minus y squared. So this is a mathematically true statement. Okay, this helps us multiply a lot easier if we can see this pattern. All right, now what I'm going to do is I'm going to use what I'm given from this statement and try to arrive at our answer, this x plus y. And I just kind of looking at it, I already see x plus y. All right, so let's plug in what we know. The first part, this first statement that we're given, is x squared minus y squared is 8. All right, well that's this part. It's saying that, you know what, this part over here is 8. Okay. We're multiplying two things, so let's just go ahead and put a set of parentheses. We're given that x minus y is 2. Alright, x minus y, instead of writing that, I'm just going to put a 2. Okay, and this gets into the question, what is the value of x plus y? Well, x plus y, what can this be? So what I'm really asking is, it's what can I put there to make this a true statement? So 2 times what gives me 8. Okay, and I think very simply we can see that it is 4. Okay, this problem is not testing whether we can multiply. It's testing us whether we can see this property here and use that given what we have and using that to get what we need. Okay. All right, number 25. What value of c makes the expression y squared minus 9y plus c a perfect trinomial square? We could try to use this. We've done the box method before. This term right over here, typically this is where I take my b term, divide it by 2, and square it. Okay. Now this equation, or this expression, is in standard form of a quadratic. It's ax squared plus bx plus c. Okay. And looking at this, I can see that our b term, that's in front of our variable, is negative 9. Okay, so let's use that. Alright, so instead of writing b divided by 2, I'm going to put negative 9 divided by 2 and square. Alright, when I have a fraction that's being squared, I square the numerator and the denominator. So in the numerator I'm going to write negative 9 squared, and the denominator I'm just going to write 2 squared. Okay, negative 9 squared. That's negative 9 times negative 9. That becomes a positive 81. And 2 squared is a positive 4. So this expression, or this term that we put into here, is just this. It's 81 divided by 4. And looking at our answer choices, that is D. Okay, so I think that's it for polynomials or quadratics here. Moving on to this next section, we're now getting into, looks like, data. So let me just go ahead and read it. So for questions 26 through 29, use the dot plots of the two data sets. So we have set A and set B. And number 26, it says, which distributions are symmetric? Okay, so just so we know, there are three different types of distributions. There is symmetric, where symmetric just means that you're balanced, you don't lean one way or the other. There is skewed left. Skewed left, with this is where we have a bunch of data, and the data is mainly off to the right, and we have a tail that points to the left. Okay, and skewed right. Okay, just kind of in the opposite sense. With this, we have most of the data on the left, and a tail that points to the right. Okay, so we have fewer and fewer data that is greater than what we have. Okay. So looking at set A and set B, if I were to put this on a scale, I don't think it leans one way or the other. So it seems that both A and B are both symmetric. So going off, I'm going to be going back and forth on this page. They're both symmetric, so it looks like C is our answer. Okay, very good. Alright, 27. Which data set has a larger mean? Our answer choices are set B, or set A, B, and neither. Okay, the means are the same. Alright, so let me go over here. Now, when you have a symmetric distribution, your mean is actually equal to your median, and it's perfectly right in the middle. So looking at set A, I'm just going to draw a line down the middle. Okay, I'm going to do the same thing for set B. It looks like this is the middle as well. Okay, so looking at this, where I just drew that line, this looks like where x is 5. Okay, our x just being a variable to indicate our data set. And over here, of our b's, it's right over here. It's in between 4 and 6, so it's also 5. Okay, so our answer for this, one isn't greater than the other. Our answer is C, that both of these means are equal. Okay, number 28. Number 28, there's a lot of confusion on standard deviation. All I want you to understand is that standard deviation, it's a measure of spread, how spread apart the data is. So if the standard deviation is a small number, so let me put if it's a small standard deviation, so SD. Okay, so standard deviation is usually just one number. It tells you how far apart it is. It's just a way, it's a unit or a way to measure the spread of the data. So if that number is small, that means all the data, so I'm going to put data is close. It's close together. Okay, if I say that from you and me, it's only 2 feet away, right? We're pretty close. We're standing right next to each other. Okay. Now, if that number is large, so if we have a large standard deviation, okay. Well, if I say between you and me, there's 100 feet away, we're 100 feet away from each other, we're probably not that close. Okay, so if that's a big number, that means that the data is far apart or further apart. Okay, or we're not quite as grouped together. Okay, so for 28, we have the choices of which has the largest standard deviation, set A, set B, or neither. They're both the same. Okay. Now I want you to look at these. I want you to look at picture that we have the center and how close is it to the center. Okay. So set A, if you look at it, all the data, you can see that all these points or data is that it's really close together. It's really close to that line. Okay, the furthest I go is either 2 to the left or 2 to the right. And over here, we don't really have kind of a clustering like this. It's almost uniform with this 3 on 5 in the middle. Okay, and this is further apart. Okay, so if it's further apart, this is where the standard deviation is a little bit bigger than this. So if we look at that, this is larger standard deviation, and it is set B. Okay, set B is our answer for this. Okay. Now for the last one may take, or for our data, may take a little bit of time, but it says the two sets are combined into a single set of data. What is the median of the combined set? Okay, well it's saying, you know, if I combine set A and set B, put it all in one dot plot, where would the median number be? Now we could probably look at, based on both of them, they were both 5. So that leads me to think that it's 5. But just to make sure that I am checking and not just taking this for face value, what I'm going to do is I'm going to create a dot plot. Okay, I'm going to create a dot plot using both the data sets on here. Okay, it looks like from our data that we're given that the furthest left we go is 2. So we're just going to go by there. It looks like the biggest number that we have, I believe, is 8. Okay, and we'll stop right there. Okay, and both of these, well, how many 2's do I have? Looks like we just have 2 2's, so I'm going to put 2 X's. How many 3's combined? We have 2 on the left and 2 on the right, so this will be 4. Okay, 4's, it looks like we have 5, so just put as best I can. I'm going to try to organize this. I mean, it seemed like it. Our 5's, we looks like if you're looking on your packet, we have about 8's. Okay. I'm writing this out. It looks like it's straight. Okay, so 1, 2, 3, 4, 5, 6, 7, 8. 6, it is 5. Okay, now I'm starting to get the idea that we're kind of getting a pattern, because 7, there are 4 of them. And 8, it looks like there are 2 of them. Okay, if you look over here, it looks like it's pretty symmetric. Maybe not based on my drawing, but the middle number, it looks like it doesn't lean one way or another. It's somewhere right in there. If I wanted to cross a number off of here, just to kind of see which one is my middle number here, we will find that our median is 5. So by looking at this, yep, our hypothesis was correct, and it is 5. So our answer for this is C. Okay. All right, now we're going to change gears here. Now we're looking at graphs. We're moving away from data. We kind of have seen these odd graphs. These odd graphs are called, this is a piecewise function, meaning that it kind of has different pieces to this. Let me just read the statement. It says the postage of a letter weighing a given number of ounces is shown in the graph below. Okay, so you can look at our x-axis. This is the weight of it in ounces. So we have 1 ounce, 2 ounce, 3 ounce, 4 ounce, and 5 ounces. And on our y-axis, this is the cost given how much this postage or this letter weighs. Okay, so we have 50 cents, $1, $1.50, and it goes on. Okay. All right, so let's use this to help answer these questions from 30 to 32. So for 30, it says a letter weighing less than 1 ounce costs 50 cents. Okay, so 1 ounce, let me look right over here. So we're looking everything to the left of this one. All right, well, if I look over here, this is kind of where it reaches 1. And I'm looking at all this space right here. Okay, is this 50 cents? Okay, it looks awfully close to 50 cents, but it's not quite. This is not 50 cents. It's not quite on that line. So this is a true or a false statement. Okay, the value for this actually is it's 45 cents. Okay, so not too much off. 45 cents. So not too much math here. Just analyzing a graph. That's all we're doing here. Okay, so for 31, a letter weighing exactly 3 ounces. I'm gonna underline 3 ounces. That's important here. Costs $1.05. Okay, is that a true or false statement? So I'm gonna go to 3 ounces. Look right over here, and I'm gonna look up at my graph. Does it cost $1.05? Okay. Now you can kind of see that it crosses the graph at this point and at this point. Okay. Whenever you see an open circle, that just means that it's not crossing there. It crosses up to there. A closed circle meaning that it is going to cross over here. So this $1.05 is actually over here, but it's open. So it's telling me, you know what, don't look over there, look over here where it is included in this plot. So this number is actually, I believe it's 85 cents. So it's not $1.05. So this is a false statement because it is 85 cents. All right, and now looking at number 32. 32, it says if 1 ounce is added to the weight of the letter, the cost increases by 20 cents. Okay, so by looking at this, it looks like we are increasing. For every ounce, it's kind of taking another step on this stair here. All right, well, like we said, this was 45. Let's go by 20s. Let's see what it is. So if it's 1 ounce, it's 45 cents. Okay. So it's telling me that if it's 2 ounces, it should be 65 cents. 65, I can't say it for certain, but I have a good inkling that it's probably 65. All right, let's just go another one. So if it's 3 ounces, it should be 85 cents. All right, that looks like it's 85, and I think we mentioned that here. And if it's 4 ounces, it should be $1.05. And we kind of get the idea here, right? It is a little bit above $1. That's probably $1.05. And then this next one is $1.25. Okay. So it looks like for every 1 ounce that we get, we increase in our weight, it looks like we are increasing. The price is increasing by 20 cents. So this is a true statement. Okay. So true statement meaning A is our answer for number 32. Okay. All right, almost there, just 3 more. 33. 33, I think I told you that there was a math correction for letter C. Instead of it being x squared or x equal to 2 plus or minus 2 radical 5, cross out this 2. Okay, you can make this a 1, whatever, but that is what was supposed to be right over here, and having said that, that is our answer. All right, it is C. But let's work out why it is C. With this, you're going to have to use the quadratic formula. So quadratic formula. Alright, so let me go ahead and write the quadratic form. So x equal to negative b plus or minus, we're going to have b squared minus 4ac, it's all over 2a. Okay. Now with this is in standard form, so that helps me. I can immediately find what is my a, b, and c that I'm going to input into the quadratic formula. A, looking over here, is 2. B is negative 8, and C is a negative 2. Alright, we'll just go ahead and put that into here, and we're just going to simplify. We're going to have, instead of negative b, our b is negative 8. So I'm going to have a negative 8, which means it's a positive 8. Plus or minus, let's just input what we know. B squared is going to be negative 8 squared, minus 4 times a, which is 2, times c, which is negative 2. It's all over 2 times 8, which is a positive 2. So all we did here was just take our a, b, and c and plug it into this equation. And what I'm going to do from here is now I'm going to simplify. Okay, so this be very careful with this. Inside our square root is where the majority of mistakes happen, so make sure that you take your time with it. Alright, first up, negative 8 squared. Well, negative 8 times negative 8 is a positive 64. Okay, we have a product. We're multiplying three numbers. I'm just going to go ahead and multiply them all together. Negative 4 times 2, well, that's a negative 8. And negative 8 times negative 2, well, that's a negative times negative is a positive, so that's a positive 16. Okay, and in our denominator, 2 times 2 is 4. Okay, if we add the numbers inside our square roots, we're going to have, so we have 8 plus or minus radical 80. 64 plus 16 is 80 here. And that's going to be equal to, it's going to be over 4. Now this square roots of 80, we need to simplify, so I'm going to go ahead and simplify that here using a factor tree. Alright, so some numbers I can go into 80, or probably, let's say 2 and 40. To break up 40, we can go into 2 and 20. 20, let's do 4 and 5, and 4 can be broken up into 2 and 2. Alright, with this, when we want to simplify square roots, we circle our pairs at the ends of our branches. So we have a pair of 2, another pair of 2, and we have this single 5. Okay, when we simplify our square roots, the pairs go outside, and these single numbers go on the inside. So 5 stays on the inside. Okay, sorry, but you can't go outside. These two numbers, so it means I could take out a 2 and take out a 2. So those are both staying outside the square root, but the thing is, I want to, you have to combine these, you have to multiply them. So 2 times 2 is 4. So this square root of 80 simplifies